Hey, Algebra 2, this is Mr. Roberts. We took a little quiz today in class. It did not have 4 questions, it had 3 questions. Whoops. Um, and for all three of the questions, basically you were given this function f of x. It stayed the same for each question, and there's several transformations of that had to occur, right? One of them was question 1 asked you to take that function, move it 6 units to the right. Question 2 asks you to move it 5 units up, and then after you move that up, you were going to do a vertical stretch. So when we do a vertical stretch, we're pulling everything equally away from the x-axis. Vertical stretch by a factor of 3. This one, had 2 transformations we had to do. Number 1 had only, or geez, number 1. This was question 2. And this was 3 on your paper. Sorry about that. Question 3 said only had 1 transformation you needed to do. You needed to do a horizontal compression, pushing everything towards the y-axis by a factor of 1/2. So part of it is knowing, the mechanics, or actually having just the translations memorized. But then the other part is the mechanics of how we write those down notationally. The first one is a 6-unit shift to the right. So if I have a function f of x, I can translate that to the right or left by using the following rule: f of x minus h. And the deal is that if h is a positive number, if I'm subtracting a positive number, right? If h is positive, greater than 0, it moves to the right. And if h is a negative number, if h is less than 0, it moves to the left. Please notice that it is x minus an h. So I'll either be subtracting a positive or I'll be subtracting a negative value, left or right. On number 1, I ask you to subtract it 6 units to the right. I don't know why I did to the left up here. 6 units to the right, which is in the positive direction. So it's going to be an x minus a 6. So let's write the function g of x. G of x, this is my answer, g of x looks a lot like h of x, except instead of, g of x looks a lot like f of x, except instead of placing x's in the function, we place x minus positive 6's in the function. So x minus 6's go into it. So if you look at that, this is the answer, right? I just need to do what this says. So what it does is it says, okay, g of x equals, now I need my function f. F is 2/3 x minus 5. So I'm going to grab that 2/3 times something minus 5. Here's what's different. Normally for f, I just put plain old x's into it. In order to do this transformation, instead of placing in x's, I need to place in x minus 6's. This is going to be an x minus a 6. So that is the answer, and the line above it was the answer, right? The thing is it's simplifying and getting g of x so that we understand what g of x is. So now I'm just going to use the distributive property. I'm going to distribute this 2/3 to both the x and the negative 6, and that gives me that it's 2/3 x, and then 2/3 times 6 is that's just the number -4, right? That's negative 12/3, which is -4. And don't forget, I still have a minus 5 up there. One last line of simplification, right? G of x is going to equal 2/3 x minus 9. So this right here is the transformation, 2/3 x minus 9. And if we graph this, we will totally see in GeoGebra or any app that you download from the App Store or the Marketplace or the Google Play Store, you're going to see that this will shift this function over exactly as described, 6 units to the right. Let's do number 3, because I think it was a simple one too. 2 has got 2 steps involved. I'm going to save that for last. So number 3, it says, let g of x be a function that results from a horizontal compression of f of x by a factor of 1/2. Find g of x. Okay, horizontal compression. Well, my rule for horizontal compression looks like this. F of x gets mapped to horizontal compression. 1 over b times x. Oh, I'm sorry, f of 1 over b times x. So similar to question 1, I'm going to be changing the argument that gets passed to the function, right? I'm going to be passing it 1 over b times x. So let's go ahead and follow this, right, notationally here. It's going to equal, let's see, g of x will equal f of 1 over b. I'll simplify this. 1 over b, the value they gave me for b, the factor is 1/2, so it's going to be 1 over 1/2 times x. So that's 1 over bx. Well, let's simplify that, right? 1 over 1/2 is 2, so g of x is going to look like f of x, except instead of passing in x's, we're just going to pass in 2x to it. So I think I can write g of x now. G of x equals, let's write down what f of x was. F of x was 2/3 times x minus 5. But remember, playing the part of x is 2x. If I simplify this, that's 4/3. So g of x equals 4/3 minus 5. 4/3 x, my bad. 4/3 x minus 5. Okay, so last question then. We've got these two steps. By the way, I'm going to box that. I need to make myself a little bit of room to do this question, so I'm going to erase some of this stuff from question 1. Sorry, it's gone. So let's do question number 2. So question 2 has two steps. First of all, we're going to be shifting everything up 5 units, and then we're going to be doing a vertical stretch by a factor of 3. So let's move everything up 5 units first. My ultimate goal is to end up with the function g of x, so I'm going to move to a function in the middle, right? I'm going to not go to g of x first. I'm going to transform f into h, and then once I have this function h of x, I'm going to do my final transformation and transform h of x into g of x. So let's just do the first part, right? So this first function, I'm going to call it h of x, is going to look a lot like the function f of x, but here's the difference. When I want to do a translation up or down, right, all I need to do is add or subtract from the functional value, from the output value. So in our notation, the transformation, if I'm being consistent with what I wrote for 1 and 2, the transformation looks like this. In order to transform f of x that way, we just take and we take our value f of x and we add to it some value k. If k is positive, it has the effect of moving the entire function up. If k is negative, it moves the entire function down. So we transform f of x into this new function. So here, I'm just going to, it's f of x plus my translation. I'm going up 5 units, so it's going to be a plus 5. So I can write this now, this h, right? H is going to look like 2/3 x minus 5. So I've got the 2/3 x minus 5. But then I come along and I'm going to add 5 to that. So this is great to simplify, right? H of x is a nice looking function. H of x is very simply 2/3 x. So we're done. We're not done. We've done our first thing. We've translated the entire function up 5 units. When I look at it, I understand that, yeah, that makes total sense, right? In fact, I probably could have done that in a shortcut way. I'm just trying to learn this notation. H of x is equal to 2/3 of x. Now I need to do my vertical stretch by a factor of 3. Whenever I want to do vertical stretches or compressions, right, the mapping looks like this. F of x gets mapped to, very simply, a times the function. So when I'm doing things, horizontal stretch, horizontal compression, horizontally, notice that I changed the argument. It becomes 1 over b times x. That was in number 3. But up here, I'm going to multiply the output by some value a. So f of x gets mapped to a times f of x. So I can see that if my stretch factor is 3, right, it's very simply going to be g of x is going to look a lot like 3 times the function I left off with, which was h of x. 3 times the function h of x. And the function h of x is 2/3 x. So g of x equals 3 times the function 2/3 x. Now if I simplify that, 3 times 2/3 is just 2. So here's my answer, g of x equals 2x. And again, I encourage you to graph those, right? This is the answer. And you would see if you graph this that first of all, the original function f of x is going to be slid up 5 units. And then the next thing that you'll see happen when I do a vertical stretch is away from the x-axis. As I move away from the x-axis, you're going to see it get taller. Right? You're going to see it stretched up. Also, when I do this vertical stretch, the x-intercept is not going to change, right? The y-intercept will change, but I'm moving away from the x-axis, so both above and below the x-axis are going to be pulling away from it. The one place that remains unchanged is that x-intercept. So I encourage you to graph all 3 of these and kind of look at them and see that, yeah, these are the transformations that Mr. Roberts claims are happening. Short video. That was the quiz that we took on Wednesday.